Next problem, the local authorities in a city installed 2000 electric lamps in streets. If the lamps have an average life of 1000 burning hours with the standard deviation 200 hours, what number of lamps might be expected to fail in the first 700? After what period of burning hours would you expect that 10% of lamps would have failed and would be still burning? Assume the lives of the bulbs are normally distributed. So this is also very simple. Substitute, given mean mu value equal to 1000, sigma value equal to 200. Substitute this mean mu value and sigma value in standard normal variate. And first question we are asked to find x less than 700. Simply substitute this x equal to 700 here. This is nothing but the value here. That is probability of z less than minus 1.5, and this can be written as probability of z greater than minus 1.5 because of symmetry. Because of symmetry, this is 1.5. Okay, 1.5. So therefore, this entire area 0.5 minus the required probability value p of 0 less than z less than 1.5 and 1.5. 1.5. How to calculate 1.5? 1.5th row, 1.5th row and 0th column. Okay, 1.5, because 1.5 is available in the table. 0th column. This value is nothing but 0.4332 referring the normal table, and subtract this value from 0.5 and simply multiply with the 2000, then we can get 133.6, that is approximately 134 bulbs. And next, for first question, let x1 be the period after which 100 bulbs would have failed. That is x1. We don't know what is x1, what is the period. So we simply assume x1 is the period. This 10% is nothing but this 0.1. 10% is 0.1. Therefore, this value is nothing but z value. This is z value. Okay. Therefore, this z value is less than x1 minus 1000 divided by 200. That is probability of z less than x1 minus 1000 divided by 200 equal to 0.1. Keeping the term here. That is probability of z greater than 1000. You see, less than, by using symmetry property, this can be written as x1 minus 1000. Therefore, if you simply multiply this with minus symbol, then probability of z greater than 1000 minus x1 divided by 200. That is, this z is greater than means 0 less than z less than 1000 minus x1 divided by 200, because z is greater than this x1. Z is greater than x1. So therefore, we can get a 0.5 minus the area lies between this case. Therefore, 0.5 minus probability of 0 less than z less than this value equal to 0.1. So you take this 0.5 to right hand side, 0.5 to right hand side, and adjusting the matter, probability of 0 less than z less than 1000 minus x1 divided by 200 equal to 0.4. And referring the normal table 0.4, this is 0. Referring the normal table in reverse order. Referring the normal table in reverse order. So referring the normal table in reverse order. This is very important and different formula, different problem, because for this type of problem we have to refer the normal table in reverse order. Therefore, referring the normal table in reverse order, then we can get the ordinate is 1.28. Ordinate is 1.28. How to find out ordinate is 1.5? This is 0.4, no? So 0.4. Simply see, I shall see its normal value 0.4. So where is 0.400 occur? You simply see 0.39. So you see 0.8. This is 0.2190. 0.2517, 0.2823. So we are going to refer the normal table in reverse order. We are given the area for which we have to calculate the ordinate. So 0.4, 0.399. You see, 0.3997 is nothing but 0.4. It is very near to 0.4 only. 0.4. So this ordinate refers to 1.2, and see here what column, 1.2 and 8 column. So 1.28. 1.28 is the required ordinate for this value. So cross multiplying and adjusting the term, we can have x1 equal to 744. And similarly, let x2 be the period after 10% of lamps would be still burning. See here, probability of x greater than x2 equal to 0.1. As usual, probability of z greater than x2 minus 1000 divided by 200 equal to 0.1. But that is, multiplying using symmetry property, adjusting the term, x2 minus 1000, x2 minus 0 less than this value. You see this value, this value, and this z is greater than this value is symmetrically plotted in this normal table, but therefore this can be written as 0 less than z less than x2 minus 1000 divided by 200. That is equal to 0.4. Okay, here you have to note here 0.5 minus of this value. That is what I am coming to explain you now. See here, this is the value. Therefore, to calculate this area, we can write it as 0.5. 0.5 minus this probability term. This probability term is simply, I note it as P. That is equal, this is P, that is equal to 0.1. So take this 0.1 this side and taking that this probability function to right hand side and rearranging the term, then we can get this entire term. This entire term, probability of 0 less than z less than x2 minus 1000 divided by 200 equal to 0.5 minus 0.1 is nothing but 0.4. So 0.4 is, as usual, 0 referring the normal table in reverse order. 0.4 is the area. This 0.4 is area. The same for previous problem also. This 0.4 is the area. So approximately 0.4 area, 0.4 level of area, we can get the ordinate 1.28. So cross multiplying and adjusting the numbers, then we can get x2 equal to 1256. So this is the answer for second question. After 1256 hours, 10% of lamps would be burning.